Welcome once again to Sean White's Solar and Energy Storage Podcast. This time we are going to talk about rapid shutdown. Rapid shutdown is something that's in the National Electrical Code. And the 2014 National Electrical Code is when it first came out. And then it's in the 2017 National Electrical Code. And there's special things that are happening for people that adopted the 2017 National Electrical Code on January 1st, 2019. And so we're going to talk about all of this stuff. It's almost like there's three different things going on, even though there's two code cycles. And let's just talk a little bit about like what rapid shutdown is and why it's important. Rapid shutdown was put in place so that firefighters would feel safe putting out fires on buildings. So rapid shutdown only works for buildings. And firefighters historically have been a little bit hesitant about saving buildings that have electricity generated from the roof. They are afraid that they're going to get shocked. Even if the solar system didn't start the fire. Rapid shutdown is not about solar systems starting fires. It's about a firefighter feeling safe putting out a fire on your building. Let me give you an example. There was a fire a couple of years ago that came up, and it burned down 500 of my neighbors' houses when I was living up in Calaveras County in the Sierra Nevada foothills. And it didn't burn down our house, but it came right next to our house. We had a ground-mounted solar array. The firefighters were running like crazy trying to put out different fires, and they didn't know which ones to do. I call it triage. That's what triage is actually a medical term. When you go in and there's a lot of people that are wounded and they figure out which people can we save and which ones are we going to skip over. Well, the firefighters saved our house, but if we had solar on the roof, maybe they wouldn't have saved our house. And the insurance companies look at things like this. And so we want insurance companies not to raise people's insurance when they put solar on their roofs. So we don't want to discourage people from putting solar on their roofs, and we require rapid shutdown of PV systems on buildings. And that is the name of 690.12, rapid shutdown of PV systems on buildings. And so a couple of things that we're going to talk about is the 2014 version of the National Electrical Code, the little bit of evolution right there. And so first, what we had in 2014 of the National Electrical Code is we just had to have the conductors that go, say, from your inverter on a typical house up to the rooftop. We don't want those to be energized when the system is turned off, or at least when the rapid shutdown is initiated. And what we would do, a couple of different things. One thing is we would put the inverters up on the roof, because once you turn off the AC side of an inverter, the AC totally goes off with an interactive inverter. And then you have the DC side of the inverter. If it's like right next to the array, then it's safe up there. And so the limit from being how far away from the array for the 2014 National Electrical Code was 10 feet from the array outside of the building. And so as long as you had an inverter within 10 feet of the array on the outside side of the building, that would qualify for rapid shutdown, because all interactive inverters, that means grid tie inverters, the AC immediately shuts off and is safe to touch within like way less than a second. And the DC side, that's the dangerous side usually when you turn things off. And if we are looking at inside of a building, it would be 5 feet from your solar array inside of the building. And that would also have to originally it had to take place in 10 seconds, but then in August of 16, there was a temporary interim amendment. That means a change to the National Electrical Code that was already in place in 2016, and they changed it to 30 seconds. And so that was 30 volts within 30 seconds, and that's for the conductors going to the array. There was no rapid shutdown requirement for inside of the array in the 2014 National Electrical Code. And so some of the ways that we satisfy the requirements for rapid shutdown of PV systems on buildings is electronics under the modules. Also, we call those module level power electronics, or MLPE. And the electronics that we see underneath the modules are microinverters and power optimizers is what a lot of people call them. However, technically in the National Electrical Code, we call a power optimizer a DC to DC converter. However, there are DC to DC converters within charge controllers. There's DC to DC converters built into inverters oftentimes, especially the inverters with multiple channels of maximum power point tracking. And maximum power point tracking pretty much means a DC to DC converter, because what you're going to have is you're going to have one voltage coming in and a different voltage coming out. And typically we do that with a DC to DC converter before it hits the inverter with modern inverters, charge controllers, and DC to DC converters. So to satisfy the 2014 National Electrical Code and to satisfy what we typically call array level shutdown of the 2017 National Electrical Code, would be having a string inverter next to the array. 2017 National Electrical Code is within 10 feet of the array. Also a contactor disconnect, which means a contactor is pretty much like a remote control switch. If you were a mechanic ever before in one of your past lives, a contactor would be like a solenoid where you turn the key, but you don't have like the big battery cables coming through where your key turns, but then it makes a switch and then it clicks on some heavy duty current going from your battery to flip that engine over. That's called a solenoid. And that's sort of like a contactor. It's like a remote control switch. So some of the things that are a little bit different between the 2014 and the 2017 National Electrical Code are the definitions of a PV system. 2014 National Electrical Code still included things like batteries and off-grid stuff, even possibly generators as part of the PV system. And we would have to shut down all these conductors going to our batteries and charge controllers and so on and so forth. With the 2017 National Electrical Code, we made new articles for things like battery, such as Article 706 for energy storage systems. So therefore, we don't have to call anything that's not part of the PV system, like loads or batteries or energy storage or generators or anything like that. None of that is part of the PV system, therefore not subject to rapid shutdown. So there's some things in the 2017 National Electrical Code for rapid shutdown that are a little bit easier on the installer. Some people might even say it's less safe and they might want to have rapid shutdown for their energy storage systems, but it's not a requirement in the 2017 National Electrical Code. So the 2017 National Electrical Code is telling us that we want to have controlled conductors also that are going to shut down to 30 volts within 30 seconds. That's going outside of the array, and the array boundary, I should say, is 1 foot away from the solar from the solar array. So it could be within 1 foot of the solar array. Typically, people would put things under the array because you can just bolt them right to a rail right there, a solar rail. And a rail also is part of the array. I have heard some funny things that some people have actually made. They'd want to extend their conductors without doing rapid shutdown. And so they would actually put dummy PV modules, because PV is getting so cheap, over their conduits, just so they could comply with rapid shutdown and go, see here, this is the array. Isn't that kind of silly? And dummy PV modules. We couldn't have never imagined that 10 years ago when PV cost 10 times as much. So the 2017 National Electrical Code, outside the array boundary, that's within 1 foot of the array, 30 volts, 30 seconds. Just remember that. And then there's some other ways that that we're going to have to, or I should say we are going to have to, or we have to, depending on where you are, because even though we talk about the 2014 National Electrical Code and it's way after 2014 right now, there's some places in our nation that are still on the 2011 National Electrical Code. There's places that are 6 years behind. So it's relevant for some people, and that's one reason why we talk about different versions of the code. But in places that have already adopted the 2017 National Electrical Code, what we have to do is we have to do module level shutdown, and that's after January 1st, 2019, which is just about right now. And so anything after January 1st, 2019, in places that have adopted the 2017 National Electrical Code, which we typically, just in general, call it module level shutdown, but there's a little bit of an exception here. And I'm just going to kind of go over the different parts that we're going to talk about. If you like learning numbers, it's called 690.12b2, and within 690.12b2, which is called inside the array boundary, there's going to be an A, listed labeled rapid shutdown array, B, 80 volts within 30 seconds, and C, non-exposed. And so let's just go over these right now. And the one that is the listed and labeled rapid shutdown PV array, as of this time, nobody has even came out with a listing yet for that. So that's not something that we can do. There are people working on that listing, and the rumor goes that that listing is pretty much going to be module level shutdown or something that works with the other two options that we're going to go over right now. And since there's no standard for that, but UL is working all the time. And so for the next one is what we're going to call is the module level shutdown pretty much. This is mostly what everybody's doing. This is 690.12 B2B, and this means that we need to get down to 80 volts within 30 seconds inside the array. So once again, I like to repeat myself so you can remember, is 30 volts 30 second outside the array boundary, and within the array boundary, we have 80 volts within 30 seconds. And why 80 volts? 80 volts pretty much means one module. So a cold temperature corrected module is pretty much going to go over 40 volts and less than 80 volts for most all modules, with maybe some exceptions for thin film because they get to be kind of high voltage, but 80 volts pretty much means one module. So if you had two modules in series, that pretty much is not going to qualify unless you had some kind of small 12 volt module or something like that. And if we look at most modules that people are using, most people are using silicon modules that are going to be 60 cells or 72 cells. And so typically a 60 or 72 cell module, one module cold temperature corrected is going to be under 80 volts, and two modules in series cold temperature corrected is going to be over 80 volts. So pretty much we have module level shutdown. Welcome to module level shutdown. And that's and so also these conductors, 1 foot from the array outside of the building, but it's sometimes hard to get through the roof. So they give us an extra couple of feet, and that's 3 feet inside of the building. It's a little bit confusing because if you think of the 2014 National Electrical Code, it was 10 feet from the array outside the building, 5 feet inside the building. But now we have the 2017 module level shutdown here, and that's going to be 1 foot from the array outside of the building. So we went from 10 to 1 foot, and 3 feet from the array when you're going through the building, inside of the building. And that's went from 5 feet to 3 feet. And that's what we have right there. And so pretty much what people are doing, if you want to see like what 99 point something % of people are doing, is they are putting module level power electronics, that's microinverters and DC to DC converters, also known as power optimizers, underneath the modules. That's pretty much the easy way of doing things, and that's just the way that people do it. Some people complain because it costs more money, and there's more things that could potentially break, but that's what we have to do to make the firefighters happy, because firefighters, they're heroes, and we don't want them to get shocked and then to fall off of a burning building. That would not be good, and the insurance companies also would not like that, and then potentially it would cost more in the long run. It does cost more to get the equipment in the short run, but in the long run, it could potentially cost more because solar insurance might go up for solar buildings burning down, buildings with solar on them burning down, not because of the solar, but because the firefighters would be afraid of the solar. And we want firefighters to be totally comfortable with solar and know how to shut it off. And there's one other way too that complies with what they call inside the array. And this was brought on to the code because of building integrated photovoltaics. And so there was pretty much no way people could do BIPV if they had to do module level shutdown. Well, I'm sure there probably is some way, but what happened is the BIPV people got them to go along with, and it doesn't specifically say BIPV, but as long as there's no exposed conductive parts, so think of things like frames of the modules being exposed, or the rails being exposed, or something that a loose wire can hit, and it's your array cannot have any metal on it pretty much unless it's like covered up. And also it needs to be 8 feet from exposed grounded conductive parts. So that means no metal roofs or anything like that. And so you could have some kind of composite made solar array that would be up on the roof. I don't know of anybody doing that right now. I imagine there's some people thinking of ways to do this. It's a little bit inconvenient for some of the traditional inverter companies because they don't have the patents that some of the people do for DC to DC converters and microinverters. And so there's some people that are upset about module level shutdown, and they should have been there at the meeting in 2014 when we came up with a lot of the proposals for the 2017 National Electrical Code. And let's go look at a few other things. There's usually the way that rapid shutdown is initiated is you have a sticker, but it could be from the main disconnect for the building. And you would just say, initiate rapid shutdown right here. Your sticker would be telling people like, this is going to turn off the PV up on the roof. It'll tell the firefighters that. But if you do have grid tie with battery backup, then you don't want rapid shutdown to be initiated when the grid goes down because you want your battery backup to work. So then you can get a rapid shutdown initiation device. So let's talk about that once again. The different types of rapid shutdown devices. It could be your solar backfeed breaker, or it could be the main service breaker. Turns off the whole building. That's the typical way of doing things. So when the power goes off to the inverter, it just initiates rapid shutdown. But then if you want to have grid tie battery backup, you will have a special rapid shutdown switch. And as we're seeing more and more batteries go onto the grid, we're seeing more and more special rapid shutdown switches. And so let's look at a couple other things about these rapid shutdown devices. One of the things is if you have like a single or two-family dwelling, 1 and 2 family dwellings, your initiation device should be located at a readily accessible location outside of the building. So if it's a bigger building, it could be inside the building. And so typically bigger buildings, there's going to have, access for multiple families. Think of like an apartment building or something like that. So the firefighters and building managers and things could get inside of there. Another thing that I'm just thinking of for 1 and 2 family dwellings, 600 volts is your maximum voltage there. That's not a rapid shutdown thing. That's just the NEC. And then your PV system on a bigger building could go up to 1,000 volts. Ground mounts 1,500. Let's talk a little bit about signs for rapid shutdown. And actually, the sign part of the National Electrical Code is not in 690.12, but it goes with it. It's 690.56, and to be more specific, we have 690.56 C1A being a rapid shutdown sign, and it's supposed to have yellow on it. Yellow is sort of like a caution color, as you can imagine from just driving down the road, and that's pretty much the module level shutdown sign. And so if a firefighter's coming up and they see a yellow sign, they're like, hey, that thing is totally safe. It could not even go up over 80 volts up on the roof. It's probably going to be quite a bit less than that, and they can feel comfortable just going up there, climbing on the solar. They could pretty much cut through the solar with their firefighter saw if they had the yellow sign. But then if they have the red sign, that means that it doesn't have module level shutdown. So that's pretty much the 2017 National Electrical Code. That would be before the 2019 requirements, or it could be a BIPV array up there. And so that red sign is going to tell us that inside of the array boundary, so up there within 1 foot of the array, you can potentially be up to 600 volts on a 1 and 2 family dwelling, 1,000 volts even on a bigger building. So to be a little bit more careful of that. And that red sign is going to be, it's going to be less and less common as we get more and more module level rapid shutdown. Then there's another sign that we can have up there too. If your building has more than one type of rapid shutdown on it, say the PV systems were installed at different times, then what you need to do is pretty much make a map of all the different types of rapid shutdown that you have up there. And then you will tell people, hey, there's all different kinds of rapid shutdown up there. It's really confusing. And then the firefighter might be like, I'm going to stay way far away from this building. So remember, a good installed PV system will probably not start a fire, but buildings burn for other reasons. And we want firefighters to feel safe putting out solar fires on solar houses. So rapid shutdown can keep our insurance rates low, and it can keep firefighters alive. So be careful and install safe systems, and know all you can about rapid shutdown by listening to this again. Hit rewind. I'm Sean White, and this is my Solar and Energy Storage Podcast. Thanks for listening.